Hello and good evening, everyone, and welcome to our new digs at York University. This is welcome to our October Recreational Astronomy Night of the Royal Astronomical Society Toronto Centre. My name's Tom Luton. Paul Markov is away this month, so I'll be running the show. Can I just get a show of hands from the folks here in the audience? Is anyone here for the first time? Yes, you all are here for the first time. Welcome, and welcome to everyone who's joining us live on YouTube. So we've got quite a few things going on this evening. Andy Beaton will be discussing Sky This Month. Charles Young will be talking about DIY power for your equipment at a dark sky site. And then Frank Dempsey will be giving us two small presentations, Frank's portable stray light shield and Mercury's salt glaciers. And then we've got announcements by me at the end. Once again, thank you to our technical team of Inyo, Ward, Andrew, and Betty who make this all possible. And we'll start off with Andy in the Sky This Month.
Hello, my name is Andy Beaton. I observe the sky from downtown Toronto under the worst possible conditions, thus proving my dedication to the business of astronomy. And I'm talking to you tonight about what we have in the sky in the upcoming month. Those who have seen me talk before will recognize the list, the big picture, key dates, the sun, meteors, aurora, the moon, planets, asteroids and comets, a double star, variable star, something in the deep sky, whatever's happening in spaceflight this month, and what we do under the terrible conditions when it's cloudy. So, starting off with the big picture. Looking west tonight, just after astronomical twilight. If we're looking just a bit to the southeast, we can see Saturn. Otherwise, we're seeing all our favorite summer constellations slowly slipping away. Spring constellations like Boötes and Corona Borealis are just setting. The Milky Way constellations, they're past the zenith and on their way down. But way off to the east, we've got our favorite fall constellations rising. If we come back the morning before our next meeting at 5 in the morning and look to the east, we can already see our favorite spring constellations starting to show up. Leo and Virgo, and not much in the way of planets arriving at this time. Mars is the only thing that's coming up in the southeast. Other than that, our favorite spring objects and all the galaxies that we find in Canis Venatici, Coma Berenices, and Virgo. So important dates coming up between now and the next meeting. We actually have two new moons. We have a full moon, a super moon on October 17th. On November 3rd, daylight savings time is ending. We have Orionid meteors peaking on October 21st. And if you're living in the South Pacific, I don't know who's tuning in from around the world tonight, but if you're going to be down there, Antares will be occulted by the moon on not only October 7th, but November 4th as well. So with the sun, nights are getting longer. Astronomical twilight is ending at 8:20 EDT tonight and starting at 5:20 EDT in the morning. When we get to our next meeting, twilight ends at 6:18 EST and then starts again at 5:05 EST. So we've got a longer night. Good news for you astrophotographers who need a nice long observing window. The sun is very active right now. Watch for sunspots and prominences. I didn't get a chance to have a look at the sun today before I came out, but the last time I did, which was a couple of weeks ago, there were a ton of sunspots. So I'm expecting that keeps on going as we're at a busy point in the solar cycle. We've got meteors coming. The Orionids are the big ones, 20 meteors an hour. Unfortunately, the moon will be pretty bright at the time that it's peaking, so we're not going to have a great show. There's a few minor meteor showers. That's 10 meteors an hour or less. The Southern Taurids, the Epsilon Geminids, Leonis Minorids, and the Southern Taurids. And below that, we have meteor dribbles, less than 2 meteors an hour. For those, I wouldn't actually bother getting out of bed to go and look for them. But if you're out there observing and you see a meteor, try and trace it back to see if it's a member of one of these small and obscure showers. Now, on October 8th, we also have the peak of the Draconid meteor shower, and that is something called a variable meteor shower. So it could be as many as 10 meteors an hour, or it could be as few as 0. And we just don't know what we're going to get until you're out there observing. So if you're out and you're seeing meteors, see if they look like Draconids. Because the sun is good and active, aurora could show up anytime. I understand there was a class 7 solar flare yesterday, which is a sign that we might have some fantastic auroras coming along. I don't have any further information about whether it's going to hit us or not. Spaceweather.com. Check it on your phone or your computer. It will have the latest updates. It'll have maps of where the aurora are showing up on the surface of the Earth. If you're under the picture of the light of the circle, get outside and look up at the sky. The picture on the back of my display here is from our last huge display. My older daughter out in BC took that. I'm very proud of her. I did see the aurora from downtown Toronto. It looked more like cirrus clouds than this, but the fact that I saw it from downtown Toronto, I mean, it was one heck of a display. So we got the moon, new moon on the 2nd, first quarter on the 10th, full moon on the 17th, last quarter on the 24th, and a surprise bonus second new moon before the next meeting. October 2nd is the apogee. That's when the moon is at its farthest in its elliptical orbit, closest on October 17th. If you're looking for a nice simple science project to do, try taking a picture of the moon at these 2 times with the same equipment and edit them side by side so you can see how different the size of the moon appears from the Earth at different times in the orbit. If you aren't bugged by the term supermoon, I actually kind of am, but I understand it's good for getting people excited about astronomy. We have a supermoon coming on October 17th, where the perigee and the full moon coincide. And this is apparently going to be the biggest moon of the year. So your people who are just learning about astronomy, get them excited about that. Then we have another apogee on October 29th. On October 9th, we have the lunar X, and what we have here is 2 craters side by side, and when the sun is hitting them at a certain angle, the crater rims light up in the shape of an X. It doesn't mean anything, but it looks neat, and it's worth having a look at. The straight wall, another lunar feature that looks really neat when the light's hitting at a certain angle. Evening of October 11th. Have a look for that then. So we have the rocky planets. Mercury is going to be in the evening twilight as we get towards the end of October. Then it will vanish. Venus is close to the horizon after sunset, but it's going to be at a weird angle from our point of view. So it's not going to be very high above the horizon by the time it disappears. It is going to be gibbous. It's going to be like a waxing full moon, only smaller, and it will get brighter and higher as we get further into the autumn. Mars is actually going to be the best of those, the rocky planets to look for. It rises not long after midnight and earlier throughout the month. It will grow to about 9 arc seconds in diameter. And once it starts getting that big, I mean, the last time we looked, it was something like 3 arc seconds across. So you could see it was there. Once we get to 9 or 10 arc seconds, then we can start seeing ice caps and features on the surface. Something I have never managed is spotting Mars moons. The best way to do that is to build yourself an occulting eyepiece, which you can read about on the internet, or wait for Mars to pass by the wall of a building or a pole, and see if you can catch the moons just outside Mars when the planet itself is hidden. I don't know anybody who's actually seen it directly when looking at the planet itself, but give it a try. We have the gas giants. Jupiter is rising around 1025. It's insanely bright. It's minus 2.5 magnitude. You can't miss it. It's so obvious that even my friends who don't know anything about astronomy point at it and say, hey, what's that? We've all seen the 4 big moons, I hope. If you haven't, they're visible in binoculars. But I know there are a lot of people here who are bored by the Galilean moons. Give Amalthea and Himalaya in the 14th magnitude range a try. Saturn rises before the sun is, before twilight is finished and will be up all night. Also pretty bright, 0.7 magnitude. The unfortunate part about Saturn is the rings are very close to edge on. You won't be able to find ring gaps, at least I couldn't. It doesn't look as spectacular as it did last year, which is unfortunate, but it's still pretty neat. I guess March is going to be when it's totally edge on. Good time to look for moons and weather on Saturn, but people looking for the rings are going to be disappointed. Moons of Saturn are interesting targets. There are 7 moons brighter than 13th magnitude, which I could see with an 8-inch telescope. Titan is obvious. The others are less so. You'll probably want some kind of astronomy software to be able to identify them. The ice giants way out in the middle of nowhere. Uranus rises around 8:30 in Taurus, just brighter than 6th magnitude, so easy with binoculars, even possible with the naked eye if you know your sky well and know where you're looking. It's about 4 arc seconds across, and the Observer's Handbook lists 5 moons that an amateur's telescope should be able to find, a largish amateur telescope. I am always puzzled by the color of Neptune. Sometimes it looks blue and sometimes it looks green, and sometimes I can't really tell. So I'd be interested in what you people observe. Post it in the comments on the YouTube show and let me know what you think. Neptune rises before sunset. It's in Pisces. It's just brighter than 8th magnitude. It's even smaller. You're not going to see any surface features on either of these planets, but you should be able to see a disk. Triton is the only moon of Neptune I've ever seen, and I don't know if anybody has ever seen anything else in an amateur telescope. And same problem I have with Uranus. I can't tell if it's blue or if it's green. Same question to the people watching. Tell me what color you think it is. The dwarf planets. I hope Nicole isn't watching because she thinks Pluto's a real planet. Pluto's in the sky all night in Capricornus, 14.5 magnitude. I've seen it once back when it was brighter than 14th. It's tough. The best thing to do is get it by imaging. Take images over multiple nights and look for that tiny moving dot. I shouted, I have seen Pluto when I saw it. You're entitled to do it too. The other dwarf planet we'll be able to see is Ceres in Sagittarius. It sets before midnight, about 8th magnitude, and it moves rapidly. So an interesting project with that is to watch it as it moves 5 arc minutes a night from night to night. We've got asteroids. I like asteroids because I like to see something new and different every time I'm out observing, and there are so many asteroids I haven't seen that I will never run out. There are a half dozen asteroids brighter than 10th magnitude currently. If you're interested in tracking them down, I can't really show you a picture in a slide that will help, but coordinates are available in your observer's handbook or in most planetarium software. So we have a big comet, C2023A3 Tsushinshan, I hope that's how to pronounce it, Atlas. I'm hearing predictions that will be as bright as third magnitude. I've heard many comet stories in the past. I'll believe it when I see it, but I'm still going to go out and try and see it every opportunity. Mid-month, it should be coming into the evening sky. It'll be in Virgo until the 14th, in Serpens Caput until the 19th, and Ophiuchus until the next meeting. See it as early as you can. It's going to be at its most spectacular as close to the sun as we can see it. The longer you wait, the further it's going to be from the sun, the less spectacular it will be. This is the one everybody's going to be talking about for the next few months, possibly for the next few years if it really gets to third magnitude. So make every effort you can to get out and see it. Comet 13P Olbers is in Virgo. A bunch of us saw it back in the summer. I guess it's still technically visible. It'll be close to the horizon and almost 10th magnitude. So it won't be easy, and it's probably not going to be spectacular. But if you want to boast to your friends who have already seen it that you're one of the gang, it's still achievable. So in memory of my old friend Blake, I always like to bring a double star into one of these. He's the man who got me hooked on them. 70 Ophiuchus is the one I've picked this time. A 4.2 and 6.2 magnitude pair. They're about 7 arc seconds apart, so you want to telescope 6 inches, 150 millimeters aperture or greater. But the reason I like this one is it's got a very fast period of 88 years. So it's moving in 4 degrees of its orbit every year. So every time you get out there, make a very careful sketch of where it is and go back every year for as long as you can keep observing. You should be able to see a significant part of its orbit. And here's a little map. There's the three bright stars up at the top left of Ophiuchus, and then 70 right beside it. I'm hoping that you've all got star maps of your own, but if you don't, you can pop back into this video and see where it is. Now, it wouldn't be my presentation if I didn't talk about variable stars. And T Cephei is the variable star I picked this time. It's a classic Myra long-term variable, and it varies between 6 and 10.3 magnitude over a 388-day period, and it's a very well-settled period. What's happening with it is a dying star, and it can no longer find the balance between gravity and radiation pressure from internal fusion. So gravity will squash it down, the fusion will pick up, it'll puff out again, then the fusion isn't enough to keep it puffed out. So internal fusion fails to keep it full and gravity squashes it down again. It's noticeably red. It's visible all year long from Toronto's latitude. And it is part of the American Association of Variable Star Observers Legacy Observing Program. Now, with long-term variables, tracking them for direct scientific purposes isn't really that useful anymore. There's an awful lot of automated sky surveys that are going to see this more than once every 388 days. But we have a database going back to 1911 when the AAVSO was founded with visual records for this star. And in order to properly calibrate the automated observations with 100 years of visual observations, they want us to keep observing and reporting visual brightness. That way they can calibrate what the eye sees and what the robot telescope sees. So this is a chance for everybody to contribute some useful knowledge to the world of astronomy. Okay, now this is the one that all the variable star observers are waiting for. T Corona Borealis. Yeah, we're getting two variable stars this time. Also known as the Blaze Star. Normally 10th magnitude, but every now and then it have an outburst up to 2nd magnitude. It's a recurrent nova, which means material is being slurped off its giant companion onto the surface of a dwarf. When enough material accumulates, fusion begins and the brightness leaps up by 8 magnitudes. The last time it happened was 1946. It was supposed to happen this summer. When I checked this morning, it had not yet happened. So it's going to happen, and astronomers around the world are eagerly awaiting this exciting opportunity. So I would say, get out there, have a look. It's going to be an easy one to spot. We have a little map of Corona Borealis here. A nice, obvious constellation in the sky. I hope many of us have seen it. If you're looking at it and look to the bottom left corner of it, that's where T Corona Borealis is supposed to be. And when it erupts, it will be the brightest star in that constellation, so you'll know it. If you're the first person to report that to the AAVSO, eternal glory will be yours. So I like to find something in the deep sky. This is the season when M45 comes along, the Pleiades. This is a good beginner object because it's really bright. You can see it with the naked eye right from the city, but get a wide field telescope out to the dark and you can see vast numbers of stars in it. Now, why is it called the Seven Sisters? Well, here, let me show you a picture. As you can see, there are 6 bright stars. So I don't know why it's called the Seven Sisters. It's a mystery. I'd be curious if anybody out there knows why. I've heard all kinds of theories. One star exploded. There was a planet there. I haven't heard anything convincing yet, but I'm curious to know if there's a solid story for it yet. It makes a good visual acuity test. I know people have reported seeing 14 stars rather than the 6 that I can see with the naked eye. My eyes are not great. Once again, if you're watching the YouTube channel and you've seen more than 6, let me know. I'm curious. If you're not excited by this thing you've seen a million times, then set up your telescope and see if you can see the reflection nebula mixed up in the cluster. See all those blue streaks all over the place. I've never confirmed seeing it. I've seen something that looks like it, but the odds are higher that my optics are just kind of smudgy. So you need really clean optics to go for this one. Something a little more challenging, NGC 6826, the blinking planetary in Cygnus. It's a 9th magnitude planetary nebula, the shell of a dying star expelling its atmosphere, with a 10.5 magnitude central star. Now, what's neat is when you look directly at this and look directly at the star is bright enough that the nebula around it will disappear. Look away, you'll see the nebula, but probably not the star. So it's kind of a neat little thing about how your eyes manage things in the dark. Yeah, throw in a nebula filter, you'll see it all very nicely. And it's part of the RASC Finest NGC Objects Certificate Program. And if people don't know about the certificate programs, I strongly recommend them. They're a good incentive to get out and observe, and they're fun. And you get a certificate and a pin, and everybody admires you as it gets handed out at the meeting. For people who are beyond even looking at a mere planetary nebula, Stephan's Quintet is an object I can't see with my own telescope. I can only see it when I borrow someone else's. And it looks like that. It's a cluster of 5 galaxies in Perseus, 4 of them a real cluster, 1 of them just coincidentally in the field of view. NGC 7317, 18A, 18B, 19, and NGC 7320 is the imposter. All around 14th magnitude, well out of the range of my 8-inch telescope, but a challenge for people with a larger telescope and darker skies. 2 of them are closely interacting. If you have a very large telescope or you're imaging, see if you can get the bridge of material between the two. And 7320, even though it's a faker, it does have a bunch of red H2 star formation regions, which should be imageable and maybe observable if you have a very large telescope. So coming up in the world of spaceflight, we have this perpetual Starliner gong show. The astronauts, last I heard, were stranded on the space station until well into 2025. The last I heard was that Falcon launches are put on hold after a mishap with the last Dragon capsule. And apparently the Starliner spacesuits are not compatible with the Dragon capsules. So we'll see if those astronauts ever get home. Hopefully not too long. I mean, can you imagine, taking a 3-day space flight and being up there for 6 months? Do you bring enough space underwear? Really? Yes, Gilligan's Orbit, someone in the audience shouts out. October 4th, United Launch Association is testing their Vulcan rocket. ESA is launching a Hera mission to the asteroid Didymos, one that was visited a few years ago on October 7th. And on October 10th, NASA is launching the Europa Clipper on its way to study Jupiter's moon Europa, one that I am very curious about. Early November, Blue Origin is going to be launching their New Glenn rocket. At least that's the plan. We'll see what actually happens. And of course, we always have the ISS flying overhead. Heavensabove.com is a place to go for ISS predictions for your local, your own personal location. I still think it's fascinating after all these years to see the space station go overhead. And I'm told that we're very close to the peak number of astronauts in space between the ISS, the Chinese space station, and various other missions going on. Now, if it's cloudy, it does happen. Galaxy Zoo is my go-to place for citizen science projects where you and I get to contribute to science without actually having to be a professional scientist. 4 that I thought looked very interesting: Galaxy Zoo Euclid, images from the Euclid mission that they want you to classify. There are hundreds of millions of objects being cataloged here. They point out on the webpage that the odds are high that you will be the first person to ever look at some of these objects. So there's an interesting project for you. Exoasteroids is one, looking for asteroids around different stars. Cloud spotting on Mars, and the Gaia Very project, the Gaia Space Observatory, looking for objects that have changed over the past few months. So any questions, feel free to email me at andybeaton@gmail.com. I'm on Blue Sky and the RISC Toronto Centre Forum, where I will be happy to answer any questions I can. Thanks very much.
Thank you very much, Andy. A question about Mars. You said it's 9 arc seconds with an 80-millimeter telescope under a dark sky. Would I be able to see the polar caps?
80 millimeter is not very big. You're not going to get a huge image with that. So I'm going to say...
Just visual?
Yeah, just visual. I'm going to say probably not, unless you're getting a moment of absolutely impeccable seeing. I wouldn't count on it.
Okay, with my 10-inch Dobsonian, will I be able to see it?
Yeah, no question.
No question. Thank you.
Thanks, Andy. Just scratching my non-clinically diagnosed OCD. On your asteroid slide, you identified 1036 Ganymede. I think there you've added an extra E because it's the same name as Jupiter's moon. It's 1036 Ganymede.
One day I will have a presentation that has no typos in it.
I have
But
no
today
claim
is
for
not the
this
day.
is a fault of mine.
That is almost certainly autocorrect fixing my presentation for me, but you are correct. The asteroid does not have an E in the name. Yes.
Not technically a question, which I suppose makes me a bad astronomer. But if you would like, anyone from RASC would like to apply for 1 meter images of Mars, the time application form is open to RASC, actually RASC Toronto Center in particular. So if you would like to retrieve any of those, it doesn't require you to be certified.
Okay, that's actually fascinating. I would like some.
You can have them.
Okay, I think that's it for questions from the audience. Anyone? No, nope, nothing online. All right, Andy, thank you very much.
Okay, thank you.